Welcome to the Essentials of Algebra 1. I'm Stuart Harrington and I am your guide through the modules of this course. This first module covers the process of adding and subtracting polynomials and consists of 3 required activities and 1 optional activity. So let's get started. In our lives, we combine things together that are alike all the time. When you go into 7-Eleven or a racetrack to purchase some things, you see right away that all the candy is located in one area, all the snacks, the chips and crackers, etc. are in another area, all the soft drinks are located in another part of the store. All of those sections are located in specific places to make it easier for you as the shopper to find what you need. Similarly, when you walk into a department store, if you're wanting to buy clothes or items for your home or anything, all of those like and similar items are grouped together. You have a section of the store that is for children's clothing. You have a section of the store for clothing for adults. You have a section of the store for shoes, a section of the store for appliances. So all of those similar items are spread out around the store to make things easier for the shopper to find what they are looking for. In mathematics, we have to be very careful and meticulous about putting like things together. Now in mathematics, we call it combining like terms. Let's begin today by talking about what are like terms. And you'll see that that is literally the first objective on our list today, identifying like terms. So let's talk about what are terms? Well, terms are numbers. They can be numbers. They can be positive numbers, they can be negative numbers, they can be fractions, they can be decimals. A number can be a term. If a number is just by itself, remember, we call it a constant, and that can be a term. What else can be a term? Another thing that can be a term are variables. We can have an x as a term, an a is a term, a delta, which looks like a little triangle. It's a Greek letter, but it's used in some mathematics classes as a variable. Another way that we can use variables as terms is to multiply variables together. It would also be true to say that the term x times y. You could have a times b squared. That can be a term. The third category, and this one's the most common probably in Algebra 1 and mathematics in general for that matter, is a combination of numbers and variables. What does that look like? Well, you might have 3 x's, all right? Or you could have 4 a's. You could have 6 a's. You could have 5 xy's. You could have 0.45 deltas. All of those things are possible for terms. Now, I can also add to that, and I could say you could have 1/4 x. You could have negative 3a. You could have 6xy squared. And we could also have 1/2 x. Let's go with a squared. Okay, let's do that one. Let's take a look at these, because the next thing we have to do is, once we understand what a term is, and all of these things are terms, we have to be able to identify which ones are like terms. Now, by definition, a like term is any term that has the same pattern of variables and has the same pattern of exponents. It's real simple. Same variables, same exponents. So let's look at what I've got down here. I have a lot of things that are quote-unquote common terms here. For example, all of these numbers, all right, all of these numbers, those are all common terms because they are alike. They're like terms. Okay, so when we're talking about like terms, all of our constants are going to be like terms. Now, let's look at the variables. What are these other guys? What other types of like terms do we have? Well, let's look at these a's. See, I've got 4 a's right there. I have 6 a's there. Negative 3 a's right there. Those are like terms as well. It doesn't matter what the number in front of the variable pattern is. Anybody know what the number in front of a variable is called? A coefficient. You should know that. The coefficient is the number that's in front of the variable. all of these variables here with the a's are like terms. However, look at this guy right here. 1/2 a squared. It's got an a in it, but it's got a squared. It doesn't have the same pattern of exponents on it. Consequently, it is not considered a like term with just the regular old a's. They're different, so you can't put those together. What other like terms do we have here? Well, we've got some like terms that are x's, okay? Got some like terms that are x's. Let's see here. These guys are like terms. That goes with them together there, okay? Oh, there's another a. That's a like term, so let's put it in there with the a's. The variable that we've got there with the delta, that's kind of all by itself. There aren't any others with that, so that's its own term. We do have a pair of xy's. Look at that. All right, those are like terms. Same variable pattern. It's an xy. Exponents are the same. And then we've got this ab squared sort of hanging out over here. Nothing to pair with that one either. Okay? That takes care of this first objective of identifying like terms. You should be able to look at terms and say those two are alike, that one is not. So let's go on. Let's now talk about objective number 2, which is how we combine terms. Once we figured out what terms are alike, how do we put them together? We simply add or subtract the coefficients. We put those together. Most of you can handle money and you understand how to add and subtract money. And you know that if you have $3 and your parents give you another $10, okay, and then you have to pay $7 for lunch or dinner somewhere, okay, if you can get dinner for $7, please tell me where. You know how to combine those terms, okay? Now, this is simply a variable expression, 3D, $3 plus $10 minus $7. You simply ignore the D for just a minute and realize that you're just working with dollars. They're all the same term, so you simply combine the like terms. So all of these are alike, all right? And so I really should have probably covered that plus sign right there. So 3D plus 10D plus negative 7, we simply need to combine the 3, the 10, and the negative 7. 3 and 10 is going to be the 13. Negative 7 added to that will be 6. Consequently, our answer to this is that we're going to have $6 or 6D. That's all we do when we combine like terms. What are some problems that we might be able to do with that? Our first problem that we're going to work with is going to be 4a plus 5a. Our second problem is going to be 6b squared minus 2b squared. Let's look at the first one. You'll notice that there are two terms in this expression. There's a 4a and a 5a. We call those terms because there's two of them attached together. We call the whole expression a binomial. Bicycle, bifocal, that prefix means two. Consequently, a binomial is going to have two terms in it. Now, I can combine both of those single terms into one term. 4a plus 5a. Ignore the a's for a minute. We know that that's going to be the common term. What's positive 4 and positive 5? That's going to be positive 9. So we have now combined the two terms that were in a binomial into a single term. If it's just a single term, it's called a monomial. Monomial, some people say. Now, look at this second problem here. 6b squared minus 2b squared. Are these terms alike? Yes, they are. They have a same pattern of variable and the same pattern of exponent. Those are the two criteria, remember? So 6b squared minus 2b squared. Well, the answer is going to be something b squared, and we need to know, okay, what's a 6 combined with a positive or with a negative 2, I should say. Well, that's a total of 4. So 4b squared will be the answer to that. Okay, let's carry on to something that looks a little bit different now. This is called a trinomial, by the way. There are 3 monomials stuck together, so that's called a trinomial. How would we combine this? Well, they're all like terms, so my answer is going to be something C, and I've got a positive 2, a positive 3, and a negative 7. You should be able to combine those three numbers together. 2 plus 3 is 5. 5 plus a negative 7 is going to be negative 2. So the coefficient, or the number in front of the variable, is going to be negative 2. Next question. Now, these are all like terms. The D is going to be in our answer. We simply have to combine the coefficients. Well, what are the coefficients? If I'm looking at this particular expression right here, there is no number in front of this. In mathematics, if we don't put a number in front of the variable, it's always understood to be a 1 sitting right there. Okay? Mathematicians, believe it or not, do like to take shortcuts every now and again, and so there are some acceptable shortcuts. One of them is we don't always have to say we've got $1 or we've got 1x or 1a. We can say we have $1, we have an x, we have an a. But when we do combine the like terms, we've got to remember it's there. So in this particular problem, we are looking at combining a positive 4, a negative 1, and a negative 2. And when we combine all those together, 4, negative 1, and negative 2, we end up with an answer of positive 1. So my answer is positive 1D. But again, we don't have to write that 1 because it's understood to not be needed or necessary. So we just leave our answer as D. What about this one here? 7a minus 3b. Hopefully you've recognized that those are not like terms. A and B are different. They're not the same variable. I cannot combine those things together. So 7a minus 3b, if we're instructed to combine that together, we can't do that. We simply say that that's going to be 7a minus 3b. That's the answer. That's all we can do. Again, look at this one. 9x squared minus 7x. Now, both of these do have an x, but the exponents are different. And the exponents, remember, must be the same in order for us to combine them. So this problem, 9x squared minus 7x, I can't do 9 minus 7. I can't put those together. So the answer, just like in this previous one right above, is simply going to be 9x squared minus 7x. Can't do anything to it. Let's go back up here. Let's take a look at our objectives. We've talked about identifying like terms, and we've talked about how to combine terms. Next on our list, we need to be able to add polynomials and subtract polynomials, objective number 4. Let's get into that conversation right now. Looking at that problem, where are my like terms? I have a like term here and here. Those are alike. 5b, nothing goes with it. Different term. So when I go to combine and simplify that particular expression, we're going to have 9a's plus 5b's. Now let's look at the next problem. Look closely at this one. What are the like terms that we have here? I've got an x term and another x term. I have an a term that has nothing going with it. So what's my final answer going to be? Well, I'm going to have 4a's because I didn't change that one. Now let's combine the coefficients. We have a positive 4 and a negative 6. That's going to combine to a negative 2. So negative 2x will be my answer here. I want you to take a quick look at these two answers that we have created. 9a plus 5b, 4a minus 2x. I put those answers in the order that I did because normally in math we want to put terms in alphabetical order. First problem had an a and a b in it, and so we had the a before the b, and the second problem was the one where we had the a first followed by the x term. Next set of problems, take a look at these guys. Now let's look at the first one. What are the similar terms here? What are the like terms that we can put together? Well, I've got a constant 4 and a constant 2. Those can be put together. I also have a negative 3c and a positive 6c. The c's are like terms. What's my answer going to be? Well, the way I'm going to write it is as follows. When you have a variable and a constant in your answer, the variable term goes first. The constant always is going to go last. No matter what the expression is, you put the constant at the very end. So I have a negative 3c and a positive 6c. Those are combined into a positive 3c. And then when I combine the constants, I have a 4 plus 2. Well, that's a positive 6. So we're going to write plus 6. Let's now look at the second question. 12m squared plus 5q plus 7m squared. Are you spotting the like terms already? Hopefully you are. Those, the first and the third one, are alike. And then the middle one is different from all of those. M comes before Q in the alphabet. So that's going to be the term we write down first. So let's look at the m squareds. How many of those do we have? 12, positive 7. That's positive 19 m squareds. All right, 19 m squareds. And then the plus 5q just gets written along. Nothing to combine with it. Final problem down here. Take a good hard look at this one. What are my like terms? I've got all these a's and b's everywhere. Are they all like terms? Actually, they are not. We've got a ab right there minus a 3ab right there. Those two are like terms. This one is an ab squared. It's different from just an ab. Likewise, we have an ab squared over here. That means we're going to put the ab's together, and we're going to put the ab squareds together. Now, what order do we put these in? Normally, you put the ones with the highest exponent first. All right, so we're going to put the ab squareds together first, and they're going to be written down first. Negative 3 ab squared right here, positive 4 ab squared here is positive 1 ab squared. Oh, but we talked about how mathematicians don't need that 1 because it's understood. So just an ab squared would be what our answer would be there. How many ab's do we have? Well, we have a positive 5 right here. We have a negative 3 right here. Positive 5 and negative 3 is a positive 2. So that's going to be plus 2ab. And that will be our answer for those problems. Let's move ahead and visit about adding polynomials and subtracting polynomials. Here is a problem that you might see in an Algebra 1 homework assignment. What I would like for you to recognize is that you have a 3 outside the parentheses. That should send off a yellow flag in your mind that says, oh, I'm going to have to use the distributive property. Distributive property is something you first began learning way back in at least 7th grade, maybe 6th. How do we distribute 3 times x plus 7? We're going to take this 3 and multiply it times x. I'm going to get 3x. I'm going to take the 3 and multiply it times 7. I'm going to get 21. 21 is positive, so it's plus 21. And then I've got over here, I've got the plus 4x because that doesn't change, and the minus 5, that doesn't change. They're just sort of hanging out waiting for all the distribution to get taken care of. Now it looks exactly like the problems we were working a moment or so ago. We've got like terms, x's right here, and we've got like terms, constants right there. So we're going to put those together. We've got 3x plus 4x. That's going to be 7x. 21, positive 21, and negative 5, positive 21 or minus 5. That is going to be 16. 16 is positive, so we're going to put plus 16. So the simplified version of this expression is 7x plus 16. Let's do another one. Here is a problem that's very similar to the one we just did, but now we've got a number that also needs to be distributed, but it's not a positive number, it's a negative number. This 8 plus 4a just going to hang out while we do the distribution. First thing we're going to do is distribute negative 3 times a. That's going to be negative 3a. Negative times a positive is negative. And then a negative 3 times a positive 5. Again, a negative times a positive. That's a negative, and we've got 15. Now we're going to combine things together. What's going to be combined? 4a and negative 3a. And then we're going to have the two constants put together as well. Final answer that we're going to receive here on this one, 8 plus negative 15. That's going to be negative 7. So remember, all constants go at the end. So minus 7 is going to go off at the back of the answer. And then the a minus 3a, or a and negative 3a, so that's going to be this, positive 1a. Oh, by the way, we don't have to write that positive 1. So I'm going to get rid of that. So my final answer is just very simply a minus 7. Let's step it up and let's get into the polynomials. Why we're here today is to learn how to do these polynomials. Everything we've been talking about up until this point has been setting us up to do the problems we're going to do right now. Take a look at this one. When problems have parentheses in them, we have to remove the parentheses. We can't solve problems that have parentheses in it. A few minutes ago, we distributed. When we used the distributive property, the parentheses went away. But now there's nothing really to distribute here, so we just need to decide how we're going to remove the parentheses. And here's rule number 1. If the sign outside of the parentheses is positive, or if there's no sign outside the parentheses, you can just erase the parentheses. It's great. All right, real easy. So if you look at this particular problem, you've got this first set of parentheses with nothing out here. So that simply means all I need to do is just erase that parentheses. It's not necessary. It's just kind of extra baggage on the problem to make sure it's really clear what the problem is saying. Look at the second parentheses. It's got a plus sign in front of it. I don't need the parentheses if there is a plus sign in front of the parentheses. So what happens here? I've got this plus and I got this minus. Well, we would read that as plus negative 7. Or you can just simply say, I don't want to pay attention to that plus sign anymore because I'm just going to look at the negative 7. So now I've got 1, 2, 3, 4, 5 terms, and I need to put them together by like terms. So I'm looking through this and I've got a 5x squared. I have a 6x and a negative 7x. Those are like terms. I've got this plus 1 and I've got a plus 2 that are like terms. I'm going to put all these together into my final answer. I'm going to put the variable with the highest exponent first, working my way down, and remember the constant goes at the very end. So you probably could say this with me. The first term is going to be 5x squared. There's nothing to go with it, so it just remains the same. The x's are going to come next, and I've got 6x minus 7x, positive 6, negative 7. That's going to be a negative 1x. So it's going to be minus 1x. Oh, by the way, we don't need that minus 1 because we never have to put a 1 in front of it. But the minus sign stays, just the 1 gets erased. And then we've got the constants, the positive 1 and the positive 2. That's going to be positive 3. So there's my final answer. That is how we work a problem with a plus sign in front of parentheses or no sign in front of parentheses. Let's take a look at this next one. As you look at this problem, you will see we have a set of parentheses. Remember, we got to get rid of them. But this one has a minus sign in front of it, or a negative sign if you want to consider it that way. We cannot just simply erase like we did previously. We have to do a little work. We're going to start off with just the 3a squared plus 4. Nothing happening with those friends. They are just sitting there waiting for the other part of the problem to be sorted out. This is like having a negative 1 out in front. So that's something we're going to have to distribute. If it's just a positive 1, we don't have to worry about it. But a negative 1 has to be distributed. So watch and remember what the negative 1 is going to do. It's going to flip all of the signs inside the parentheses. Negative 1 times a squared minus a squared. Negative 1 times 2b, negative 2b. Negative 1 times negative 4, positive 4. Critical to your being able to work these problems accurately is being able to multiply, divide, add, and subtract integers properly. So now we need to identify the like terms. We've got an a squared and an a squared right there. I've got a constant. Do we have any more? Yep, sure do. There's one. And then I've just got the minus 2b hanging out right there. So what is my final answer going to look like? Well, we've got a 3a squared minus 1a squared. That's going to be 2a squareds. The plus 4 and the plus 4, that's going to be a plus 8. But remember, that goes at the end. So I'm going to write that outside there and kind of leave a gap for me to put the answer in. And then what's left in the middle is the minus 2b. And so this is my answer simplified to that problem. Let's put 3 more very similar problems on the screen and see if you can figure these out. If you'll notice, these problems are very similar. If you look inside the parentheses, it's all the same. The first parentheses, 3c squared minus 4c plus 4. The second parentheses, negative 2c squared minus 4c plus 7. Same thing on all these. The only thing that's different is that we have a plus, a minus, and a plus. We have a plus, plus, and a minus. How is that going to make our problems different? Well, let's take a peek at the first one. Remember, we can't put these together and simplify them until we remove the parentheses. So if I look at the first problem, can I erase the first set of parentheses? Yes, I can, because out here is a positive or no sign. So I can simply erase here, erase here. Out here was a plus sign, so I could just erase that guy as well. This plus sign, I really don't need it anymore, so I'm simply going to kind of just cross it out because I don't need to worry about it right now. Okay? Now we look at our like terms. What are the like terms? We have a 3c squared minus 2c squared. We have a negative 4c and a negative 4c. And we have a plus 4 and a plus 7. 3c squared minus 2c squared, that is 1c squared, don't need the 1. Negative 4c and negative 4c, combining those together is negative 8c. Positive 4 and positive 7, positive 11. There is my answer to that guy. Let's take a look at the second problem. Very similar to the first, but not exactly the same. On the first set of parentheses, we have no sign out in front, so that one, just like on the first one, I can just erase the parentheses. It's gone. But look at the second one. The second one has a minus sign in front, and we have to distribute that into the parentheses. So let's do that. Negative 1 out here times this term right here. That's going to be a positive 4c squared. And then we're going to have a negative 1 times a negative 4c. Okay, that's going to be a plus 4c. And I think either misspoke or wrote the wrong number. I don't know what. If we go back here, this negative 1 times a negative 2, that should be a positive 2. So let's get the right number on that guy. I think my brain was already thinking ahead and it shouldn't have been. Now, the final piece of the distribution is right here. Negative 1 times the positive 7, that's going to be a negative 7. Okay, so now let's go ahead and just come in here and let's take 3c squared minus 4c plus 4, put them all together. And I don't really have to rewrite that, but I think it makes it a little bit easier. Now, what are my like terms? Do I have a 3c squared? Do I have any more c squareds? Yep, good spot right there. What about negative 4c? Are there any other c's? Yep, got them right there. Okay. And then constants. What kind of constants do I have? I've got negative 4 right there, or a positive 4, I should say, and a negative 7 there. So let's put the like terms together. My final answer, I've got 3c squared plus 2c squared. That's going to be 5c squared. Look at what happens here. Negative 4c plus 4c. Negative 4c plus 4c, that's 0. we don't ever have to write zeros. This is another agreement among mathematicians. If there are no variables, in other words, it's a zero coefficient, you don't have to write it. Just like you didn't have to write the 1. Now if it's a 1, you got to write the variable. But if the coefficient is 0, you don't even have to write the variable. Just leave it off. So we're not even going to put the c into the answer. Our final term is a positive 4 and a negative 7. That's going to be negative 3. So we'll put that down for my answer. So here is my answer to the second problem. Now the third one. What happened here? Well, on this one, we've got a negative outside the first parentheses, a positive outside the second. So let's do the easy one first. We can just get rid of this right here, okay, because it had a positive sign in front of it. So let's take a look at that. We can get rid of the plus sign. We're not going to have to worry about that. Now let's talk about the front parentheses. We have a negative outside it, so we're going to distribute the negative 1 times the 3c squared. So that's going to be negative 3c squared. Okay. We're going to have a negative 1 times a negative 4c. Okay. That's going to be a positive 4c. And then we're going to take this negative 1 times the 4. And that's going to be a negative 4 right there. The next ones just came along for the ride. Negative 2c squared minus 4c plus 7. We look for our like terms. I have c squared here, c squared here. I have a 4c right here, a negative 4c right there. And then I've got this negative 4 and a positive 7 there. So when we go to write our final answer, negative 3c squared, negative 2c squared. That's negative 5c squared. We have a positive 4c and a negative 4c again. Those cancel out, so we don't have to write anything. And then the negative 4 and the positive 7, that's going to be a positive 3. Okay? So our final answer again is going to be this negative 5c squared plus 3. This concludes the presentation of the content for this particular module. At this time, you will move on to video number 2. Video number 2 is only practice. No new instruction, just practicing the skills we have already talked about. There are some specific instructions for that video, and I will give those to you in that video. So we'll see you next time.